Welcome to the Whispers of Deep Time. I'm Alan, your host, and this is a podcast where science meets faith. Each podcast will tackle various topics from God to geology and life in the universe, while searching for clues in our very existence. Join us as we take an objective view of the universe, searching for telltale signs of design and, most importantly, the designer. Before we go any further, and for full disclosure, we are people of faith, believers in a creator, and believers in science. But just because we are people of faith doesn't mean that we won't be objective. In previous episodes, we examined cosmology, genetics, and the origin of life. Today, we turn to physics, specifically thermodynamics, and ask the question, does the second law of thermodynamics constrain evolution or biological change? And more broadly, what does entropy imply about the direction and limits of natural processes? Thermodynamics is often invoked in origins debates, and it is also frequently misunderstood. Today, we will define it precisely, apply it carefully, and apply its implications honestly. The second law of thermodynamics states that the total entropy, which is a measure of disorder or the number of possible microscopic arrangements of an isolated system, can never decrease over time. In simple terms, natural processes tend to move toward greater disorder and energy dispersal. In a closed system, total entropy tends to increase over time. Entropy is often described as disorder, but more precisely it is a measure of the number of microstates corresponding to a macrostate. In practical terms, energy spontaneously disperses. Heat flows from hot to cold, and systems move toward thermodynamic equilibrium. The universe itself is trending toward maximum entropy, often called heat death. This has many implications for cosmology, but what about biology? But is the Earth a closed system? A common objection to thermodynamic critiques of evolution is that the Earth is not a closed system. It receives energy from the sun. Therefore, it is an open system. This is correct. The Earth receives trillions of watts of solar energy each day. So, local decreases in entropy are entirely consistent with the second law, provided the total entropy of the larger system increases. Snowflakes form, crystals grow, convection cells organize, and energy flow can produce order. Therefore, the second law does not prohibit local increases in order. This has been scientifically settled, and there are no questions remaining. However, an important distinction must be made. Thermodynamics addresses energy distribution. It does not directly address functional information, nor can it do so. A snowflake is ordered, it grows to an expected general form, but it does not contain algorithmic instructions. Living systems exhibit low entropy, functional integration, and digitally encoded information. The key question is not whether energy can produce order. It clearly can. The question is whether unguided energy flow can produce specified functional information. Thermodynamics alone does not answer this question. The second law also establishes a direction to time. Processes are irreversible at the macroscopic level. For instance, egg scrambles. They do not unscramble, and stars burn hydrogen. They do not spontaneously reverse fusion. This directionality supports the cosmological conclusion of a beginning. If entropy has been increasing, it cannot have been increasing forever. An internal universe would already be at equilibrium. The thermodynamic arrow reinforces the case for a finite past. But does biological change over time violate thermodynamics? The answer to that question is no, as long as energy flows into the system, entropy increases globally. Local biological complexity is permissible, but permissibility is not sufficiency. Energy input does not guarantee the emergence of functional systems. For example, shining sunlight on sand does not generate computer chips. Energy and intervention is necessary. It is not self-sufficient. The organizing principle remains the key issue. Researchers in non-equilibrium thermodynamics have shown that energy gradients can produce spontaneous pattern formation. Examples include Baynard convection cells, chemical oscillations, and crystal growth. These phenomena demonstrate self-organization under energy flow. However, such systems follow fixed physical laws. They do not encode symbolic information, and they do not replicate with variation. There is a categorical difference between patterned order and algorithmic instruction. Living cells contain instruction sets. Self-organizing chemical patterns do not. Information processing has thermodynamic consequences. Landauer's principle demonstrates that erasing information requires energy. Information is physically instantiated, but thermodynamics does not explain the origin of meaningful sequences. It describes energetic constraints, not semantic content. The emergence of genetic coding involves symbol-to-function mapping, error correction, and translation machinery. These are hallmarks of communication systems. The second law does not forbid such systems, but neither does it explain them, nor can it do so. As we see, this infers design. On cosmic scales, entropy continues increasing. Stars will exhaust their nuclear fuel, and galaxies will dim. The universe tends towards maximum entropy. This reinforces two major points: that the universe had a beginning. The universe is not self-sustaining indefinitely. Its physical resources are finite without intervention. A cosmos governed by thermodynamic decay is contingent. However, it does not explain its own existence. Intelligent design does not argue that entropy disproves evolution, rather biological change. That claim is scientifically inaccurate, but does prove direction. Intelligent design asks, does energy flow plus blind mechanisms adequately explain the origin of specified biological information? Thermodynamics allows complexity, but it does not generate semantic code. When we observe energy, matter, information integration, we must evaluate whether undirected processes possess sufficient causal power. That is the live debate. So what can we conclude? The second law tells us that the universe is running down, that time has direction, and that systems decay without input. Open systems can develop order, but the origin of functionally specified information remains unaccounted for by thermodynamic principles alone. Physics constrains possibility, which infers design. Does it not fully explain biological meaning? No. Meaning has theological implications. Entropy reminds us that the universe is not eternal, not static, not self-sufficient. Energy flows, stars burn, systems decay, and yet in the midst of this drift toward equilibrium we find encoded information, molecular machines, and conscious beings capable of reflection. The question is not whether physics operates. It clearly does. The question is whether physics alone is the full story. It clearly has much to conclude. Next episode, we will examine irreducible complexity in molecular machines and evaluate whether gradual mechanisms can plausibly account for them. This is Alan with Whispers of Deep Time. Until next time, good day.